we will have three different talks on different extensions as well as applications of the SSPs. And the first presentation will be by Helene BENVENISTE, and it will be on migration in the SSPs.
So the project I wanted to, first of all, so my name is Helene BENVENISTE. I'm currently a postdoc at Harvard, but right now I'm presenting work that was actually done during my time at IIASA. And this is work that analyzes the role of international migration in the SSPs. And it was joint with Jesus Crespo-Quaresma, Matt Giddens, and Ryan Mutarek. And it was actually published a little earlier this year at Climatic Change. So the point here is that you probably know that migration decisions often have many reasons and they're rarely due just to environmental stress. However, climate change can affect migration decisions both directly and indirectly. And here, I'm going to focus on three key interactions. The first picture here is meant to illustrate the fact that migration is already a widely used adaptation strategy to impacts on climate change. The second picture, which I think is really important, illustrates the fact that remittances, which are, those money transfers that migrants send back to home communities, well, those remittances really can serve as useful resources in order to increase adaptive capacity to climate change impacts also in origin locations. And finally, the fact that, of course, migration and socioeconomic development strongly influence each other in both directions. So given that, we really thought that there was perhaps a need for more explicit projections of socioeconomic development that show the effect explicitly of international migration in them. I'm really going to focus on international migration here. And this is where really the SSPs come into play. Here on the left, you can see the seminal graph by Brian O'Neill and others that shows the narratives, the 5 narratives of the SSPs. What we perhaps don't know is that in those qualitative narratives are embedded assumptions on international migration. So for SSP 1, 2, and 4, the assumption is that international migration stays at medium levels, so kind of a pursuit of historical trends, whereas for SSP 3, which is supposed to be a world that is really fragmented with perhaps conflicts and strong emphasis on security and perhaps on closed borders, you're going to see low migration. And finally, for SSP 5, which is supposed to be really driven by broad globalization, you're going to see high international migration. Now, those qualitative narratives and assumptions are explicitly quantified in the population projections, where you have explicit quantification of migration, and then the population component serves as input into all those other components I'm showing here. However, migration is entirely implicit in those other components. And so what we wanted to do here was to make the effect of international migration more explicit in those components. And here I'm going to show results for the GDP and inequality aspects. What I mean by making migration explicit, basically what we did was to develop versions of the SSP projections for zero migration. Those versions are not meant to be realistic per se. What they're meant to do is to be compared with the original SSP projections, and thereby we can highlight the effect of international migration. So the first one is, of course, population projections, and that was not done by us. It was done by Samir Casey, who is the author of the original projections. Basically, upon our request, he just reran his projections inducing zero migration in them, and so you're going to have ripple-off effects of those assumptions on migration into fertility and mortality aspects in each country over time. And then we first looked at GDP projections, and what we did basically was to take the original quantifications, at least the ones by Billink et al., and we removed from them 2 effects of international migration. First, the changes in population sizes, and second, those remittances, which are again those very important money transfers between locations. Now, in order to compute remittances, what we needed was a model of bilateral migration flows between countries. And in order to do that, we devised what is called the gravity model. So that's the first large equation here. Gravity models basically allow you to include all kinds of migration drivers in a quantitative framework. So you have the number of people moving between locations at a given time. That's going to be a function of population sizes at origin and destination. You're also going to have the effect of income per capita, YPC, both at origin and destination. And then in the second line, you have effects of proximity measures between origin and destination. So we look at the geographic distance. We look at characteristics of typical remittances being exchanged between locations. and we look at the presence of a common official language. Then we aggregate the number of people who move at a given time to have a stock variable of people who live at a given place coming from another place at a given time. And from that, we're able to derive assumptions on remittances being exchanged, basically with the assumption that migrants are going to send back money for basically the duration of their stay. They're going to send back money to their origin community and not just once. Once we have the remittances quantified, again, we're able to come back to the GDP projections and the reversions for zero migration. The other thing that we were able to do was to look at different measures of inequality, effects of international migration on inequality. We looked at inequality between countries, and we also looked at inequality within country. And for that, we needed to use the work by Narasimha Rao and others who published projections of within country inequality along the SSPs in 2019. What we did was to just calculate the changes in those numbers coming from international migration. So the migration-driven changes in particular in education drivers of inequality. Now, I'm just going to say a very quick word on an important part of the method here, which is going to be to estimate this original migration model, which is going to drive the rest of the results. In order to estimate this migration model, we use data on the independent variables available from the World Bank. That's very easy. But for the dependent variable, the bilateral migration flows, we're going to use data that is both two sources of data, column 1 and column 2, which are both derivations of estimates of bilateral migrant stocks, which are available from the World Bank. And the derivation from stocks to flows can be done in different ways. And here we're doing the estimation for two different methods. What we find is kind of in line with the literature, which is that the number of people moving between countries at a given time is going to be positively correlated to the population sizes, both at origin and destination. The income per capita at origin has a positive effect, as well as the income per capita at destination, but that effect is stronger, which illustrates kind of the pull to move towards richer locations. You have a negative correlation of distance between countries on migration flows and a positive correlation with common official language at origin and destination. Now, what we did again with this migration flow model being estimated was to derive the remittances flows and then come back to the GDP projections. And let me first show you the first result. Here I'm showing you the effect of international migration on world average GDP per capita. For both graphs, the 5 colors are the 5 SSP narratives. And on the left here, I'm showing you both the original SSP GDP projections, which are in circles, and our versions for zero migration, which are in triangles. And here on the right, I'm showing relative changes between the two for clarity. And so what we find here is that in all SSP narratives, on average, international migration tends to make the world richer. When you look at this, and that's basically due to the fact that with migration, people are able to move between countries and they're able to exchange remittances. We also do this exercise, of course, for each country, and what you find is that the effect is, of course, highly dependent on the country, but also on the SSP narrative. And in particular, the SSP narrative is kind of going to drive the exact migration corridors that are being used, so kind of where people move when they move. Now, once we have the income projections, we can also look, as I mentioned, at the effect of international migration on inequality. The first aspect we look at was inequality between countries. We use the Gini coefficient, which is a measure of population-weighted income differences across countries. And so it's a measure between 0 and 1. 1 is a lot of inequality, and 0 is perfect equality. And again, on the left, I'm showing both versions with and without migration, and on the right, the relative changes. And so what we find again here is that international migration tends to decrease inequality between countries in all of the SSP narratives. And that's basically, And the other thing we looked at, was the effect of international migration on inequality within countries, again, using the specification by Rao et al. That was done in 2019. What we found when we did that was that there was little effect of international migration on inequality within countries in most origin countries, and international migration tends to reduce inequality in most destination countries. And that's basically due to the fact that international migrants in the SSP projections tend to be highly educated. So in conclusion, what we find here is that migration tends to make the world on average both richer and more equal in all of the SSP narratives, which was not necessarily something that we expected to see. We also saw pretty important differences in the effect of international migration, depending on the socioeconomic development scenario that you look at, and of course on the location. And so what we take away from this is that if you're starting to do projections of migration in the context of climate change, it might be really important to use this scenario approach and not do like a kind of one-size-fits-all approach, because what we see is that the context really matters for projections of migration here. From a practical standpoint, I think those projections, one of the ways that they can be really useful actually for the IAM community is if you want to do modeling exercises using IAMs or other types of models, but where you want to make migration explicit, in those models, often you need input scenarios. And typically, input scenarios, the SSPs are used. But if you want to make migration explicit and you use the SSPs, you're going to count migration twice because you're already going to have it in the SSPs and you're also going to have it in the model. So kind of the idea with those scenarios is that you can use them and make migration entirely explicit aside from it. And that way you avoid counting migration twice. And with those types of framework, we've been doing some interesting applications, I think, where you can really analyze interactions between different sets of policies, such as climate policies, migration policies, and inequality policies, which are not that often considered together. And so from really a practical standpoint, we made, of course, the projections available with the paper, but we also submitted them to the IPCC scenario database of working group 3 for the upcoming assessment report. And with that, I thank you for your attention. Again, this is the reference of the paper and looking forward to questions for the discussion later on. Yeah, I just saw Brian type a question. Brian, do you want to ask your question live?
Sure. The original SSP projections assumed that international migration went to 0 in the long run. And I know like Guy Abel, I think, has done other projections that doesn't assume that. And I'm just wondering if you're using that, because that would obviously be really important to your outcomes, long-term outcomes.
Absolutely. No, we use the ones that do have 0 migration in the long run. We talked with Guy about it, actually. We talked with Guy and we talked with Samir about it. And kind of the takeaway was, because I think the UN projections on population, you would know better than me, also have 0 migration in the long run, that we wanted to do this exercise with kind of the original ones, which are kind of widely used, even if I agree with you that the assumptions that are not that widely known actually outside of the migration community, that those migration rates would kind of tend to 0 at the end of the century, are probably problematic and probably wrong. But again, what we wanted to do here was to look at the effects of international migration in those seminal projections that are being used kind of wisely. So your point is really well taken.
Mm-hmm. Yeah, thank you. Thank you. There's a question by Bas also in the chat. He is noting that at the global level, the effects seem to be small. And he was wondering whether the effect at the national level might be bigger.
Yeah, the effects at the national level, of course, are a bit bigger. You get to, depending on the places you look at, of course, the smaller the country, then the larger the effect. You can go up to, I think, 20%. So really strong effects for very small countries. But overall, the effects globally are pretty small. And that's also because international migration is not such huge numbers in terms of number of people. You stay always, like in terms of migration flows, you stay always kind of under the 1% of populations. If you look at the world region level, the migration flows, international migration flows, stay under 1% of the regional population there. So it's not like such huge numbers necessarily.
Yeah, but it's also not so small if you consider, for example, GDP effects for climate mitigation compared to the migration. They're same order of magnitude, it seems to me. Rob has his hand up, so let us take this last comment or question, and then we move to the second presentation. Rob?
Thanks, Keywan, and I'll keep it short. My question is whether you see a big difference in the effects on inequality in emigrating countries versus the countries that have the immigration.
Yeah, so in emigrating countries, you see effects in both directions depending on the country. And that kind of depends on whether, the fact that people leave, which tends to decrease output at origin, is compensated, to what extent it's compensated by the remittances being sent or not. And so depending on the country, you're going to see both. However, on destination countries, by and large, you see effects only in one direction, meaning that international migration tends to decrease inequality at destination. Sometimes it's very marginally, sometimes it's a little more, and that's entirely driven by the assumptions on the education profile of migrants.
But let us move to the second presentation, and thanks again, Helene, for a really interesting talk. The second talk is on an application of the SSPs to a national and a subnational scale, particularly the US Great Lakes region. And the presenter is Jeff BIELICKI. Jeff, please.
Great. Thank you for the opportunity to present. I realize that this title is a bit cumbersome. So I'm really going to be focusing on the Great Lakes region using U.S. Department of Energy modeling results with a specific focus on the interaction with our stakeholders on forecasting or projecting energy for this region. And I was delighted to follow a presentation that has some econometrics in it, because I also have some econometrics. I was hoping I wouldn't be the only one. So thank you. And you see the wrong version, right? Now you see the the correct version, the full display, I assume. Yeah, okay, great. So what we've been looking at, I presented last year here at the IMC in the SSP section, and what we've been looking at is the consequences of different levels of global openness, specifically around trade. We've had a period of hyperglobalization which has slowed, and now there could be some retreats from this global integration. The globalization has benefited a lot of people and nations in aggregate terms, but there's been a lot of backlash as well. Things like increasing income inequality, exporting, decreased environmental conditions. And this deglobalization trend may continue as we have a higher preference for local foods. We've got increasing nationalism and a lot of protests against trade and its institutions. So the Great Lakes region of the United States is a fairly significant contributor to the overall activity in the nation. Over the last 20 years, about 15% of the economic output and roughly 15% of the population lived there. It comprises the 5 US states of Michigan, Wisconsin, Illinois, Indiana, and Ohio. And this is a National Science Foundation Food, Energy, Water project. So we're focusing on the implications, potential implications of changes in global integration to food, energy, and water systems in the region. It's an important region. It has a substantial amount of agriculture, mostly corn and soy. It also has a long history of conventional fossil fuel production, and over the past 15 years or so, a very substantial amount of unconventional natural gas and oil production due to hydraulic fracturing. And the Great Lakes, up here, the 5 Great Lakes hold roughly 20% of the world's freshwater resources. So it's a very important combination of food, energy, and water. And we have a number of issues in this region, one of which is our harmful algal blooms due to nutrient runoff from agriculture. This is the western half of Lake Erie, I'm showing here in the satellite photograph. So again, as I mentioned, we're interested in understanding how changes in global integration, which we're operationalizing through trade, may affect food, energy, and water systems, and in essence, sustainability in the region. And we've got this scenario matrix where we're establishing 5 scenarios with various levels of higher or lower sustainability or higher or lower trade, and a BAU scenario in the middle. Now, obviously, there's a global context and a national context and a subnational regional context in which the region is embedded. So what we have to do is make sure that we can produce scenarios that are harmonized with these different spatial scales. And these scenarios are going to be run are being run in a number of models. We've developed global and national market models, a dynamic model, and a regional computable general equilibrium model, as well as a farmer decision-making model based on surveys of farmers and how they might change what they choose to do with their land, whether it's planting different crops or leasing it for wind development or for hydraulic fracturing. And these models are connected in a variety of ways. We've also got a land use allocation model and a hydrologic model to estimate the effects of nutrient runoff, nutrient application, and nutrient runoff. And they're connected in a number of ways as well. And on top of all of this, we have various sustainability assessment methods, both life cycle assessment and inclusive wealth assessments. And we're bringing in data from a regional climate model. Again, all connected in complicated ways. The scenarios are informing everything in this project, which comprises about 24 faculty and students and another 3 dozen external stakeholders. So with the scenarios, the data we've been using are from the SSPs, OECD, and US level, US at the global and national level for crop production and energy, as well as regional energy data, water quality, cropping choices at the watershed and field level, state, county, and remote sense 30-meter land use data. And we're establishing these scenarios with, as I referred to, a participatory engagement approach with external stakeholders who comprise the Research Advisory Council. There's about 2 dozen of them, and then some of them and a few others are on participatory modeling assessment teams, so roughly another dozen are on there. And of course, we have the project team. And one of the reasons that a number of the reasons that we have both these external stakeholders and the research team is that the external stakeholders are more on the ground and conducting, basically in the practice and in the field, whereas the research team, like myself, we're kind of a little disconnected from that. So the information that they can provide and the guidance they can provide is quite useful. This is a timeline of the last almost 4 years of the project and all of the meetings we've had with the external stakeholders, including the ones online due to COVID, how we've had where these meetings have been placed and the major developments along the way. I mentioned that we're interested in differences in trade and sustainability. Last year, I presented on how we parsed the SSPs into our scenario quadrants, and I'll mention that briefly. And today I'm going to focus more on how we've gone about projecting energy in specific ways. So as I mentioned last year, I spoke in more detail about how we had the Research Advisory Council cut up the narratives for the SSPs and place them on our scenario quadrants. And in essence, it converged to allocation of the SSPs in this way. And last year we had a little bit of a discussion about how the higher sustainability, lower trade quadrant was the most complicated and didn't fit as well as the others. But when you focus on the conditions in the high income countries, it's a little better fit. And the US being a high income country, we went with it. So doing this and using data, the projections from the SSPs and data from OECD and the United States, we can project agricultural yield with some uncertainty. That's showing the uncertainty here. I'm showing projections for corn, soy, and wheat according to each of the scenarios and in terms of the year-over-year change, which is and the uncertainty in it, the range of it, which is how the modeling effort wanted it to be produced. And so as I said, I'm going to focus more on how we've gone about using projecting energy. We are relying on the use of the National Energy Modeling System that the US Department of Energy uses to produce every year the annual energy outlook. They project, right now they're projecting out to 2050, and they implement various cases to see how energy consumption, demand, transportation, demand, electricity generation, and so on might evolve under various cases. So a high economic growth, low economic growth, high renewable cost, low renewable cost, and so on. So what we did is we anonymously we had the whole team, both the project team and the Research Advisory Council, assign these cases to our quadrants. And some of these projections can be available at the subnational scale. In fact, the census, the East North Central census region that the U.S. Department of Energy uses is spot on with our Great Lakes region. But some of the other data, like electricity generation capacity, is not available so nicely. It's basically by the market module regions, and so we have to be sure that we're appropriately handling a larger spatial scale. So as I said, we had all the stakeholders, both the research and the external stakeholders, assign these cases that the Department of Energy runs through NEMS to our 5 scenarios. This is the aggregate allocation of them. And then using some statistics on them, have determined what the significant assignments are. And so what I'm showing here in green is if there was a positive coefficient, in red is if it was a negative coefficient. These are the results of 2 different econometric models. And what you'll see, for example, is there was very clearly high economic growth was very significantly associated with the high sustainability, higher trade scenario, and the lower sustainability, higher trade scenario. Whereas it was the respondents very significantly shied away from assigning it to these 2 lower trade scenarios. So as an example, the high economic, there was a really clear correlation in respondents' mind between economic growth and trade. And I also looked at the differences in how the Research Advisory Council assessed the cases and how the project team assessed these cases. And remember, we tend to be a little bit more disconnected from the reality of things, and they tend to be more on the ground. And so in large measure, except for this one scenario, they were pretty consistent assessments. And so some of what we've found are that, again, tends to be this correlation of economic growth and trade, a negative correlation with oil price and trade, positive correlation of oil and gas supply with trade, and a negative correlation with renewable costs and with sustainability. These make sense and are expected. With that one scenario, though, the RAC had quite a different assessment than, or quite, well, significant different assessments than the project team, which again helps us to get a better understanding of what might actually go forward. And in essence, they were at baseline significantly less likely to assign cases to this scenario. So they either had a harder time thinking it through or grappling with it, or were less likely to go out on a limb with their thoughts about it. So when we put all these together, like I said, correlation of economic growth with trade, low gas supply, and oil price fell into these quadrants, and low renewable energy costs and high renewable energy costs are negatively correlated with sustainability. And there were also other companion treatments where we looked at carbon dioxide prices and carbon-free generation standards, but I'm not going to talk about those. So what this allows us to do then is to project how, in this case, the share of different renewable energy generation may unfold. Now, the reason the DOE projects an increase in renewable generation, but the reason why the scenarios are projecting shares is because the model that I'll talk about in a little bit more in a little bit relies on historical calibrations, and what the modeling team wanted was to project total aggregate fossil and renewable demand, and for the scenarios to determine how those would be parsed out. So there's not much technological detail in that model. You can see things like solar is increasing faster than wind is decreasing in terms of the shares, and the business as usual, which is black, is the results are pretty consistent with the lower sustainability, higher trade scenario, which is in red. Similarly, with fossil fuels, the modeling team wanted the shares. So they're going to project fossil demand, and the scenarios provide how that demand is allocated. Here you can see that trade basically is favoring the use of natural gas. And if you just look at this on its at first glance, it looks like higher sustainability favors coal, but the projections from the DOE is that there's less coal overall. And so the point is that this focus on shares can be a little confusing without digging more deeply. I'll skip that. So one of the things that through this process we want to point out is the people in the backgrounds involved in the different types of activities. And specifically, we have a hydrologist working on hydrology, but all of the modeling is being developed and implemented by people with various backgrounds in economics. And so what that leads to is that the disciplinary emphasis and assumptions and so on are passing through. Things like reliance on Cobb-Douglas production functions, the use of Carnot games, and like I said, aggregate demand without technological detail. So dominant assumptions and perspectives can be embedded. Things like choices that the farmers will make will in land use allocations will follow the highest marginal returns, rather than perhaps constraints on their capacity to change their crops, and prices reflect scarcity. One anecdote I want to share about the behind the scenes process is that one of our project team members at some point was pretty adamant that we need to be able to account for water as a constraint, for example, on energy. Others on the team said, but this region is really humid. We have a lot of water here. We don't need to worry about it. Somebody else said water is free. This is very much an economics perspective. And even one of the RAC members said, yeah, but you really do need to consider it, because we produced a comprehensive report, and in the areas where there's smaller water sources, like smaller streams, it's really a problem. But yet the price-based model without physical characteristics persists in the effort. So again, part of what I'm highlighting here is that the people in the room matter, and their perspectives and their training matters. And so the process of constructing scenarios not only needs a wide variety of people, but it also needs people who can span and translate across disciplines, as well as between researchers and stakeholders, and an awareness and attention to the team dynamics. Some of the discussions have been pretty heated, and some people have felt as though their voices have not been heard or properly incorporated. So I'll end with, given this reflection on the process of creating the scenarios with basically almost about 4 dozen people from various backgrounds and roles. We proposed a session for the upcoming scenarios forum about the process behind constructing scenarios. The SSP RCP framework has been extremely influential. For example, and scenarios are being relied on quite heavily. But less attention has been turned to how the scenarios are being produced. In particular, what I'm pointing out is that there is a lot of human decision-making embedded in the construction of the scenarios. What is plausible? What are the factors that are important, and how might they combine? How the models that are being used are constructed, and how that may influence what the scenarios are asked to provide. So overall, I've really quickly talked through how we've tried to work through and reconcile data from different scales, both bottom up and top down, and how different approaches to integrated assessment modeling can influence other parts of the project. and more specifically, how the backgrounds and the people in the room and the ways in which they interact can be influential in what the products are. That's me. I'm happy to answer questions. I'll leave this up. Thank you for your time.
Yeah, let us move then to the presentation from Joannes. And yeah, we will have then roughly 5, perhaps 10 minutes. We started 5 minutes late, so 10 minutes at the end for a discussion. And Joannes is going to talk about updated SSP GDP projections that take into account COVID-19.
Okay, yeah, hello. My name is Joannes Koch. I'm glad that you all decided to join the SSP session today, and I'm happy to present a joint work with Marian Leinbach with the title Update of SSP GDP Projections, Capturing Recent Changes in National Accounting, PPP Conversion Factors, and COVID-19 Impacts. So on Monday, in the first plenary session, we all learned about the IAM's community's decision to update the SSP scenarios. And I would just like to remind you here why the update is necessary. So first and foremost, the quantifications of the basic SSP elements are almost 10 years old now. And while population scenarios have been updated since then, the GDP scenarios have not yet. Since then, there's new and revised data available, and the COVID pandemic has occurred, which has greatly affected GDP levels across the globe. And finally, it has become more and more clear now that countries need to take action on climate change now and in the near future if there's any hope to reach our climate change targets or climate targets. Therefore, making sure that the scenarios which underpin a lot of modeling results and a lot of assessments, that these scenarios are consistent with recent data and recent economic trends is really critical. On Monday, we've also seen, I think Detlef presented, that there are these 4 levels or 4 ways at which we could update the scenarios. And I would just like to have this here to frame our update in this context and make clear that our update is a type 1 or level 1 update. So our focus is really on the consistency between the SSP scenarios with the recent historic data and trends. And yes, the community has planned a level 2 update for next year already. And once that level 2 update is out, that update will be the new default SSP scenarios. But until then, our scenarios are still very useful. And specifically, the methods and the lessons learned are definitely applicable and relevant for future level 1 type updates, because we will inevitably have to perform more updates in the future if we want to prevent the next level 2 update to become outdated also. So yes, our updates here is a level 1 type update with a focus on the recent historic data and trends. So where do we get our data from? Well, we picked our data sources as a result of a comprehensive comparison exercise of available databases that had GDP data at purchasing power parity for a number of countries. And there are not that many large databases with this information. And we compared the databases or evaluated them according to a number of criteria, one of which was completeness, shown here, but also we evaluated their credibility, their update frequency, and also how widespread they were in the IAM community or used in the IAM community. So shown here are the number of countries with available data on the y-axis, and on the x-axis, the years for which data is available, and compared these databases listed here. And you can see in the top right corner in blue, the World Development Indicator database by the World Bank is really the database with the most complete set of countries in the recent past, with the IMF in green, not far below. And there are other data sets that have very long time series, like the Madison data set by the Groningen Growth and Development Center. But for us, for our application, it's really this recent past that is important. So therefore, we chose the WDI and the WEO, so the World Economic Outlook by the IMF, as our data sources. For the completeness, and also because they're backed by these big institutions, they are reliable and they update frequently. So WDI is updated every quarterly, I think, and the WDO twice a year. So having picked our data sources, we could then create our updated scenarios. And the first step was to make sure that the units were the same from the data from the databases and in our SSP projections. So one way which we solved that was to convert the WDI and IMF data into the unit of the SSPs, which is $2005 at purchasing power parity. Having converted, we could then harmonize the data from the databases with the long-term projections. And we did that on a GDP per capita level in order to preserve the underlying narratives of the SSPs, specifically the narrative of income convergence. That is that developing and emerging countries catch up to in income-related terms, catch up to the countries at the frontier. And another benefit of doing the harmonization on the GDP per capita level was that then when computing the GDP scenarios by multiplication with population numbers, we could use the updated population projections by the Wittgenstein Center to create updated GDP scenarios. Now, the harmonization method that we chose led to these three, or can be summarized here in these 3 points. It leads to updated scenarios that are equal to the WDI data until 2020, the last year of the WDI data. So it includes data on the COVID shock. Between 2020 and 2026, the updated scenarios follow IMF growth rates. So that includes the predicted recovery, country-specific recovery of the COVID shock. And after 2026 until 2100, the SSPs follow a path that leads them back to the original GDP per capita values. And convergence to the original GDP per capita values is either accelerated or delayed depending on the SSP. Okay, so here are some results. Shown here is GDP per capita in $2005 PPP for China and India between 2010 and 2100 on the right, and the left-hand panels are just a zoom on the near term between 2015 and 2035. And what you can see right away is that, so our updated scenarios are the solid lines and the original scenarios are the dotted lines. And you can see right away that while there are relatively large income differences in the short term, these disappear in the long term, and by 2100 are zero by construction. What you can also see when you look at the left-hand panels is that all the SSPs follow the exact same trajectory until 2026, after which they start converging back to their original income levels in 2100. The effect of the COVID pandemic can also be clearly seen now looking at the short-term India panel. In 2020, income levels in India dropped below that of 2018 even, so a relatively strong effect there with a recovery thereafter. And for China, you can see income levels in 2020 actually being above those in 2019, so a positive growth rate seen there. One of the few countries that managed to keep a positive growth rate through the pandemic. And you can see the effect maybe more clearly here looking at the explicit growth rates. So for India, the average growth rate between the years 2015 and 2019 was 5%, but that dropped into minus 8% in 2020. So a really strong shock from the COVID pandemic. And actually, when you look in the list of most affected countries by the COVID shock, India is placed third. So really one of the countries most severely hit. China, on the other hand, goes from a 6.1 to a almost 2% growth in 2020. Still a shock, but relatively much smaller. So here's some more results for different countries, the same plots now for Tanzania and United States. Again, you can see that the differences in the short term disappear in the long term. And here also, again, the response to the COVID pandemic is very different. The United States, similar to India, drops low in 2020, but then rebounds afterwards. While in Tanzania, it seems that the COVID shock wasn't very strong, but looking closely and looking at the growth rates, we can see very slow recovery. So for the United States here, 2021 and 2022, very strong, very large growth rates. So a rebound effect there. While for Tanzania, even by 2025, growth rates still haven't recovered to the pre-pandemic trend of 3.1. So a very slow recovery there. So the effect of the COVID shock and these predicted recoveries are really very important for a lot of modeling teams now, and these are captured by the updated scenarios. Now, another thing that some of you may have found weird looking at these plots are these very large differences in relative terms in GDP per capita in the historic years, like 2015 here. These are very big differences. And now just computing them here in this table are listed the percent differences for SSP2 between the updated and original scenarios. Tanzania here, for instance, almost 45% higher in the updated scenario than in the original one. And these large differences are perpetuated across the globe. So on the global average, income was corrected upwards by almost 13%, or 13.5%. And for some world regions, here MEA is Middle East and Africa, almost 60% different in 2015. Where are these large differences coming from? Like, were the original projections so off? No, the answer is not that, but we can see this shines some light on the issue. Plotted here are differences in database versions between 2020 and 2012. So this is income data in the same database, just different years, converted to the same unit also. And what you can see is that across databases and across countries, income levels or GDP per capita levels have been corrected upwards by a very large margin. Now here for MEA and SSA, due to the scaling effect, is very clear, but it's across the globe. Where do these differences come from? Well, it turns out there are three reasons. Between 2012 and 2020, a new system of national accounts was adopted was implemented by the countries, and it's the SNA 2008. And it's called that way because it was actually adopted by the United Nations in 2008, but only implemented in the years thereafter. And what that means is that just GDP is being accounted differently nowadays than before. And one of the differences or the changes that had the largest effect on GDP levels was the reclassification of R&D purchases into investments rather than intermediate goods. Another reason for these differences are statistical benchmark revisions, or simply improvements to the methodologies and data sources used in the national accounting of GDP. And countries used the opportunity of the SNA change to implement their statistical benchmark revisions at the same time. And for some countries, the statistical benchmark revisions had a larger effect on GDP levels than the change of the SNA, of the national accounts. Finally, and this affects GDP at PPP, there were new PPPs published by the ICP in 2020, and these are their estimates for the 2017 reference year. And what this publication has for an effect on the time series of purchasing power parity conversion factors in the WDI, for instance, is that time series is the result of an interpolation and extrapolation exercise on the two most recent publication years of the ICP reports. In this case, now 2017 and 2011. So the 2005 PPP factor is then corrected or revised in accordance to the new time series. So those are the three reasons why we see these big differences in historical years between database versions, and also the reason why we see such large differences between our original SSP scenarios and current data, making the updates very necessary nowadays. And yeah. So to conclude, what we worked on here was a level 1 type update of the SSP GDP scenarios that preserve the SSP narratives. It still take into account all these recent changes in GDP accounting methods and PPP conversion factors, and also very importantly include the 2020 COVID shock and predicted recovery thereafter. The methods, which we didn't go into now in this presentation, are still very applicable for future type 1 updates that we hope will happen regularly, maybe even on a yearly basis in the future. Thank you for your attention.
If there is no question, I would have actually one. Yeah, Helene?
Yeah, maybe Keywan, you can go first, but so this is kind of a broader question, Joannes, and maybe it's not just for you, it's for the overall SSP community. It feels that, you know, given we're already kind of partly a few years into the SSP projections themselves, I've seen several studies who actually just say, we're just using SSP3 because that's what we see historical data following so far. I'm just wondering, to what extent can we still talk about the same 5 narratives, given that we're already probably on one path that follows more closely one versus others? I know that the SSPs don't have any probability distribution underlying them, but I'm wondering this is kind of a halfway formed thought, but I'm wondering whether you can comment on it sometime.
No, what you're talking about, I think, or what you're envisioning is maybe a level 3 type update, where you rethink the SSP narratives and build new projections off of that. And yeah, it may be that we have to think about a level 3 type update soon. Unfortunately, the level 2 update that the community has planned for next year, and I think the OECD will take the lead on that, or the OECD team will take the lead on that, is I'm not sure in how far they will revise narratives even then. So yeah, we definitely did not touch the narratives, and even the update for next year, I don't think is supposed to touch narratives, but maybe others know more on that.
Yeah, thank you, Keywan. Thank you, Joannes. So on this particular point about the system of national accounts and the updation of the absolute GDP numbers, but I'm hoping, or I'm assuming that even historical numbers now would have been updated using the sort of same system of national accounts, right? The GDP growth rates are still the same, so the methodology might have changed, but the growth rates are essentially going to be the same. And does it really matter for the long-term future, irrespective of what is the absolute number, because the growth rate would be same? It doesn't matter so much for energy and emission pathways, or does it really matter,
Well, the growth rates for the future, I mean, the SSPs, they really start in 2015 now, and they go into the future. And as you say, that the growth rates may be the same in the historical period, but in the future, the growth rates now have differ between our updated and the original scenarios. Because since and when you could think also, we could have just taken the SSP growth rates and applied them to the new levels in 2015 and run with that. But that leads to weird artifacts in 2100, because if you take a developing, or I mean, I have maybe a plot in the extras, but you're not guaranteed in using this method to keep the 2100 order of incomes between countries, the relation between countries, the same. So you may end up with Ghana having higher GDP per capita than the US in 2100 if you start at a way higher level with the same growth rates than originally. Does that make sense?
No, it definitely makes sense. I'm just intrigued by, because these are all measurement issues, right?
Excuse me?
These are measurement issues, right? We are essentially measuring historical GDP, and just because we have kind of changed the method of measuring the GDP, it has kind of ended up having a different effect on future growth rates. Thanks for that.
Thanks, Johannes. But let me perhaps first clarify the issue of the narratives. Indeed, the what you call the level 2 type of update would not yet include neo-narratives. And the process here is that we're in the lucky situation that in summer there will be the next scenario forum, where the community will come together and discuss about what's the future of the community scenarios, in which directions do we want to go, and narratives will be an important topic there as well. So we will hopefully come out of that meeting with a clear idea about which sort of process do we want to put into place to decide on which directions the narratives will go. And I think the GDP updates then can piggyback right also on that process. I think the narrative process is a little bit of a more complex one than just updating the current GDPs. But let me ask you, perhaps it was really interesting to see how you updated this, and was also interesting to see, and I was aware about this, that sometimes the historical updates of GDPs for some countries can be quite massive. Sometimes it's just because the basket changes and all of a sudden a country who is really relying on one element in the basket has all of a sudden a very different GDP than before. But also methods can change. I was wondering, I mean, it would be an enormously important service to the community if we could have perhaps some tool that could, on a yearly basis, when the statistics come out, do something what you have done. Basically, update the near-term projections consistent with the new base year that is provided. It doesn't sound like very sophisticated mathematics that you are doing, and perhaps it's even possible to have a learning algorithm, you know, which sucks the medicine data, the world development indicators, and other sources, and updates annually the SSPs, and you have a new release. Did you think about something like this?
Absolutely, that is exactly what we are doing at PIC for the Remind model. That's what we're going to do. We developed 2 R packages in the course of this work. One to convert GDP data reliably using WDI conversion factors, and the other is a package to create the scenarios, and that automatically uses the WEI data as far as possible, and then IMF growth rates as far as possible. So the combination of these 2 packages definitely, well, that is definitely the idea for our team as well, and I'm happy if we can make this more general somehow, to have yearly updates. Yeah, definitely. Yeah.
I think there would be a market for that. People would go there every year and see, oh, okay, I have to take the newest update. Yeah, and with machine learning, you don't need to hire every year a new person. The machine can perhaps take some of this on.
Yeah, we don't have any machine learning in the packages yet, but yeah, that's maybe something for the future work.
Yeah. Yeah, let me open it then for, oh, it's already 5, but let us perhaps reflect a little bit on the 3 presentations that we have seen, and please come in with any comments. I actually, Jeffrey, I really thought that your presentation was very insightful and emphasizing the exchange and the process and what we can learn with the stakeholders together. I thought that's also very relevant. And unfortunately, at the moment, there are many of those experiences. So if you look at how many papers have used the SSPs in slightly different ways than they started out in the process, but we don't have any systematic collection of those experiences that one could draw from. So I think that would be a really interesting thing to try to do. What do you think? Is it something? Is your experience something that you could systematize and try to see whether other similar processes learned in similar ways? It's more difficult actually to systematize than what Joannes, of course, was doing.
Yeah, I think I appreciate your comments and insights, and I sort of feel like I wish that we had come to this like 6 years ago, so we could have perhaps been a part of some of these thousands of papers that have been put out using the SSPs and so on. I think, I do think that there are, there's a whole fields and disciplines on organizational behavior and group dynamics and group decision-making processes and the science of team science that could perhaps be, that we're actually, some of us are digging into as a result of this experience that could actually, I think, provide context for some best practices that could hopefully be useful.
Great. I see Vaibhav, your hand is up.
Yeah, Keywan. So I'm wondering if there's some kind of work on subnational level, like GDP projections. Is that kind of work also happening somewhere? Joannes, if you know about that kind of work. So we're trying to do this for India because we're doing the state level model for India, GCAM. And we are doing this something very similar in the sense of, convergence kind of hypothesis in the long term. But what we also noted that the near-term growth rates are pretty part dependent, which is very interesting. So there are a bunch of states that are growing always at like 4%, 5%, and there are a bunch of states that are high growth states, and they're growing at like 8, 9% for the last 6, 7, 8 years. And because we have to engage with at the state level, we can't show in the near term, the next 10 years, sudden departures from these last 10 years of growth rates. We have to maintain that kind of thing, and then still, I mean, achieving some kind of absolute convergence across states became very difficult. So we ended up having these like 3 big groups. So even though there's a much more equitable distribution as compared to, let's say, 2010 or 2015, still it is not like absolute convergence. So I'm wondering if if some other subnational efforts have been made. Are there some learnings from that kind of efforts? Yeah.
Was this a question for me?
I think it was for you, Joannes.
Yeah, but
I just missed the very start of it. But unfortunately, I don't have a good answer for that. Sorry.
No problem. Thank you, Joannes.
There has been actually the activity by Narasimha Rao and others who tried to estimate, first of all, income inequalities within countries to Gini coefficients, and then this can be translated in some sort of, okay, how fast grow the poorest compared to the richest within the country. But of course, it's not different than provinces, as you indicated.
Yes. So that is more income decile kind of inequity across time.
Exactly. And there has been an activity that Matt Giddens has been leading, also trying to translate the rural-urban income differences and the Gini work into spatial projections of economic growth in the SSPs, and also taking into account, to the extent possible, and India was included in that set, subnational province level growth rates. So that work is there. It's not published yet, but a better version of those downscale GDP projections are available. Basically, ultimately, the result was to have really an income distribution in each grid cell, then based on that. And in a more simplified way, you can think about some within country conditional, not absolute, conditional convergence, but keeping rural and urban growth different and calibrating it on a province level growth if available. But most countries, we didn't have province growth. And I hope, the idea is to publish this relatively soon.
Keywan, is it for all countries? But you're saying, is it for all countries, but not all at the province level, or is it just for selected countries at this point?
It is for all countries. It is a global map of GDP inequality, but only in some countries is actually calibrated on province level information. Only there where we had information available, we did use province level. So this was India, China, US, and so on. Reliable and good data is available. And when the countries are big enough, we try to use them. To use that information. Yeah. So because many people need it, our motivation was actually to think more carefully about vulnerability, and to combine that information better with impacts, which are spatially explicit, and you want to know who is impacted. If you have very spatially different patterns in terms of the impacts, and that was the idea here. I see Elmar has a comment in there. Yeah, so the SSP updates is also available at the Navigate project. Yeah, and I should mention that this is of course a Navigate product, but this is not the main comment from Elmar. But nevertheless, I think it's really great that Navigate actually funded the SSP updates here. Shivika, please come in.
Yeah, so Keywan, on your last point, when you were saying that you are using the income inequality to understand who's where people, which people, or I should say it's one more vulnerable. So my point is, because there's a lot of interstate immigration also, so how you balance that part, or how you take into account that part? Because in a global model in SSPs, this part is like different national and countries migration is, I think, so taken into account. But when you're talking about the vulnerability, yes, current vulnerability you can handle, but when you are doing the projections, how the interstate migration, how you are taking into that account? Because there's a lot of migration between states also for work purpose, for certain part of the, I should say, season or something like that.
Yeah. So in the work that we did, I can perhaps very quickly, we did, for example, not have the information from Helene. What we did, we simply took the downscaled population projections that were available by Brian Jones and Brian O'Neill, actually, is also, I think I saw him earlier in our session. And then, yeah, basically said that's where the population is in the future. That includes, of course, implicitly migration, but migration is going to zero in the long term. So it was very, very represented in a very simplistic way, as Helene also noted in the SSPs.
Yeah, and the main difference, I think, is that you can't trace where people go. You just see like the difference in population, and you can infer that people move, but you don't really know the corridor, let's say, if that matters to your question.
Thanks a lot.
Yeah, yeah. But what you see very well in the projections is this very strong urbanization, which is going on in almost all the projections. So the future patterns are similar, but the densities of population in some areas become really high, and sometimes they become high in high vulnerable areas. So the patterns change.